Before fuzzing our function, we have to build the harness. So basically the wrapping code that wraps our function and that allow us to fuzz only the specific section of the code that we care. In that case, the choseColor function. Inside the exercise 3 folder, it's already provided an example of harness that we can use to fuzz our slice. As you can see, the code is really simple. We start by including all the necessary header files. Then we create our main function. We initialize the spec object using one of the constructor of the spec class. We have some AFL macro, and then the function that we want to fuzz, our slice, the choseColor function. This AFL macro allow us to fuzz only the code that is following this macro. So basically we are telling to the fuzzer, please don't fuzz what is before the initialization step, but fuzz only what is following. So our function, our slice. We can do that because if we look to the code of the choseColor function, we can see that it's completely independent from the parameters that are initialized in the constructors. For example, this one is the one that we used. In that way, we don't have to fuzz all the code, but we can focus only on the function that we want to fuzz, the choseColor function. The last step before fuzzing our slice is to generate the initial corpus and instrument our target. Like in the previous exercise, we can do that using a bunch of random data. So we create the seeds folder. We go inside. And we can get some data from the urando. Now we have to be sure that our slice is included in the CMake file. So if we go back to the source code, inside the CMake file, we can see that our slice, our harness, the spec slice, .c++, it's already included in the executable. Okay, now we can start our AFL++ container to instrument our target. So we need first to get the image ID of our container. We can copy it. And now we can run our container with podman run. So we are using the same command as before with the same parameter, but instead of passing the exercise 1 folder, we are passing the exercise 3 folder, and we are mounting it in the target directory under the root of our container. So now we can go inside the target directory, and we see that we have the same files of the exercise 3 folder. Now to build it, we have to create the build folder. We go inside, and we have to run CMake. But before doing that, we have to remember that we have to specify which compiler to use. That in that case, again, for both C and C++, we will use the AFL CLang fast compiler. Make. And now we can see that our slice is compiled. To conclude, we can finally fuzz our target. And we can do that in the same way we did for the previous exercise. So we can use the AFL++ binary for fuzz. We need to pass the input, in that case our initial corpus, it's under the target directory. We select the output directory, no memory limits, and we have to specify the binary that we want to fuzz, that it's spec slice. We make the terminal a bit smaller. And as you can see, we already found some crashes in our code. In this section, we explored how to use SourceTrail to analyze the source code of our target program and how to apply slicing to focus on specific sections of the code. Slicing is a powerful technique in the real world, enabling us to quickly identify potential vulnerabilities by narrowing our focus. So, instead of fuzzing the entire software, we can concentrate on the parts that interact with external inputs. To conclude, I'd like to leave you with an exercise, triaging the findings. As in the previous exercise, investigate the crash found in the crashes folder and try to reproduce them using your favorite debugger. Additionally, if you want, you can spend some time experimenting with SourceTrail and explore other functions to find other sections of the code that you can slice and build the harness to fuzz it.